Okay. So we're talking about resting and action potentials. Okay? Synapses, how they work, resting, action potential, all or none, response. These are kind of all in the same vein. So remember that you have, with each neuron, you have a charge. Okay, these ions move in, move out. Potassium, sodium. That leaves you, relatively speaking, more positives on the outside of the neuron, more negatives on the inside. The total charge that they say is about this negative 70 millivolts. Okay? And this is our resting potential. This is the nerve ready to go. It's primed. It's ready for a signal to come from the brain, right? Remember, the signals come from those synapses, sent down from the brain. The neurotransmitter goes across. Acetylcholine is the one that does most of that work. From the axon of one neuron to the dendrite of another neuron to send that signal down however far it's going. So when that signal comes, it can be either subthreshold or it can be enough of a stimulus to cause an action potential. This first diagram here, wow. The first diagram there is showing you a subthreshold stimulus. You see it only goes up to minus 62. A signal has come, right? Here is the signal coming right here that is telling it that it wants to fire, but it's not enough of a stimulus to get it going, right? It's only when we reached, in this case, it's minus 55 is kind of that threshold, that limit where once I get past that, then I engage my full action potential, right? And what happens when that occurs? Well, that's this piece here where you have the sodium start coming in. So we're at minus 70 initially, right? We receive that stimulus that is enough to get the action potential going. It's past the threshold. Are you comfortable with this threshold? Okay? It's enough that we cause an action. And it brings the sodiums in, right? And you can see here that depolarizes this whole thing, right? It takes it from minus 70 and moves it up into the positive numbers, right? Positive 20 or so. You're getting more positives inside, where it used to be the positives were outside, right? We're moving all these positives inside. And that is that depolarization. That is what's causing the signal to be sent then all the way down the nerve. It'll just keep doing the same thing all the way down this nerve. Depolarizing and then repolarizing. You see that it shifts them back out again so that, again, it gets back to that resting potential. Because who knows when the next signal is going to come. I need to be ready for that next signal. Okay? So that is basically what is forming when an action potential happens. You get the signal from the brain that has to be above that negative 55, above that threshold level, that causes the depolarization. So it brings the positives in to take it from negative 70 up to about that negative 20. Oh, sorry, positive 20. Depolarizing means you're getting rid of it being polar, right? We're taking it from negative 70 and we're going above the zero all the way up to about positive 20. Because you're getting so many positives coming inside the neuron that it makes a positive charge on the inside. And then very quickly, it repolarizes. It gets back to that resting potential. Well, that's going to take you probably a paragraph or two to say what I just said. Yeah, absolutely.
So is negative
Threshold is 55. 70 is the resting potential.
So what causes it to reach the numbers?
What causes it to get to negative 70, or I mean negative 55?
Yeah.
That's the signal coming from the brain.
So just the brain signal decides what it's going to be. And then based on that.
Right, depending on how strong that signal is. If that signal is not, if it's sub-threshold, it's not strong enough to make me get this action potential going. But if it's above that 55, that's what that all or nothing thing is. Nothing will happen unless it all happens.
But then to get it to negative 70, you have, like the sodiums or whatever have to go in?
Right. Right. That is what that depolarization is. The sodiums come in from the outside that make the inside positive now, which is what then causes a chain reaction all the way down the neuron, down the axon. But then, of course, that point is that it quickly repolarizes. It doesn't stay that positive 70, or positive 20 very long. It very quickly repolarizes, gets back to where it's supposed to be.
And when they're positive and negative, their sodium tests are both positive.
Right.
So it's just that one has more, so it's more positive?
No, they're kind of just ignoring the negatives here. There are negative ions present here. So back here you can see that there is just this overall charge of minus 70 on the inside. More negatives than positives. Yeah. Okay, so yes, there are positives on the inside still. That's what this diagram is showing. There's still potassiums in there, but there's more sodiums on the outside. So therefore, it's more positive on the outside, more negative on the inside. Okay? And then this is a diagram that's showing you that action potential, the impulse moving down the nerve. Once this part depolarizes, then it causes the next part, and then the next part, and all the way down. This chain reaction, this wave that flows down the neuron. Helpful, Christy?
Yes.
Okay, good. Other questions? Yes? Sure. So the all or none response is basically just what we were saying, that you have got to get a stimulus, a signal from the brain that's strong enough to make an action potential. If it's below that, like this is a minus 62 is all it depolarized, it's not enough. It's a nothing, right? I won't actually send a signal. It's not like I send a weak signal down the neuron. I don't send any signal. But once I get above that threshold, that minus 55, then I send it. It doesn't matter how much stronger the brain sends me signals, I'm sending that down the tract. So it's either all of it, I send it all, or it's nothing. I don't send it.
So we just need to know if it's above 50, if it's above negative 55,
Right.
then it's an all response, and if
Yes.
it's sent, and if it's not, then it's not sent.
Right. That's my threshold. That minus 55 is that minimum amount. You have to at least get it that much for me to send my signal. Yes?
So there's this one part talking about the neurotransmitters being released from the nodes and
Mm-hmm.
they go into the leftness. Talk about these things that, like these enzymes that clean them up, I guess.
Okay.
So let's say that your muscle is twitching. Is that because those neurotransmitters aren't being cleaned up and they're literally sitting in the cleft still?
It could be. Yeah, there's a number of things that can cause that muscle twitching, but it certainly could be that there's these little bit of neurotransmitters that's stuck there. Sometimes that neurotransmitter has been exhausted, and so you just get this kind of contraction that sticks around. But yeah, absolutely, it could be a problem there. Mm-hmm. Other questions, my friends? Yes?
What is the difference between action potential and impulse conduction? Or like what's impulse conduction is different than
Impulse conduction is just meaning you're sending that signal all the way down the neuron, all the way down the axon, all the way down the nerve.
So that's just a part of potential.
Yeah, I mean, the action potential is that process of making it go.
But this like chart thing that says it has the steps to it, does that not explain resting and action potential?
You're talking about this table 9.1? I would think so. Let's take a peek at it. On page 227. That's kind of the, what's the word I want? Nice little summary. 227, right? So that's the events leading to the conduction of a nerve impulse. Yeah, so that's basically telling you. Impulse conduction is that last number 8. A wave of action potentials travels the length of the axon as a nerve impulse. Yeah. Cool. It's the how. This is the how. That's what we're dealing with. How does that system work? This is how the nervous system works. Are these impulses moving down the system? Other questions?
So with your little essay and multiple choice,
I think there would be all of the above. Yes, ma'am. Yeah. I mean, something like resting potential, action potential, how a synapse works, those things are better explained through an essay type question than it is through a multiple choice kind of thing.
so like for the cranial nerves, would it just be like matching maybe or something?
I'm not going to tell you how, to be honest. I want you to know the material. Yeah. Might there be, might I have you list it, might I have you, yeah, there's all those different possibilities. It should be close. Should be close. If you meant to say oculomotor and you said facial, you know, that's a problem. Yes, ma'am.
So I think we understand this, but can you just explain to us what you want us to say about the synapse and how it works, just so that we know what's going on?
So number synapse, I mean, that's what we were just speaking of, is that synapse. Right? So here's my synapse. You tell me how this works. What happens first? Sorry? A synapse. Talk to me about how this works. I'm going to test this tomorrow, and you all should know this already.
It's between two neurons.
Okay, so the brain sends an impulse. Okay, and it comes to the junction between two neurons, you're saying, Joe. What happens? I'm sorry, I can't hear you. They're kind of mumbling a bit. Yeah.
Does it travel down the axis?
Right, so the axon is coming, right, until it gets down here to the synapse, right? That causes, that signal, that impulse, right, causes the release of these, what? The neurotransmitters from these synaptic vesicles. Remember, a vesicle is just a carrier molecule. Remember way back to when we were talking about the different parts of the cell and how things move. That's what vesicles are. They just move things around. So it's going to bring those neurotransmitters into that space between the two. Because remember, these two neurons don't touch, right? There's space between them.
What sends the vesicle down? Is that impulse?
The impulse, right, yeah, the direction from the brain. Okay? The vesicle contains neurotransmitters. See, this is the vesicle, synaptic vesicle, with the neurotransmitters inside of it.
Where is it sending neurotransmitters to?
It's sending it down to that synaptic cleft, the space between. Right? And those neurotransmitters go across that cleft. They bridge the great divide here. And they attach onto those postsynaptic neurotransmitter receptors. 3 big words, but all it's just saying is this is the place where the neurotransmitter is attached to, on the other side of the synapse. And when that happens, then what happens? When those neurotransmitters attach on the postsynaptic receptors, then what?
And they go in and they do what they're meant to do.
Right, I mean, are you comfortable that that's what this is right here? Right? That's what's happening right here. That neurotransmitter is coming across the cleft to this other neuron. And that's what sends the signal to depolarize. Are you with me? It's all tied together. The signal from the brain comes to the end of this one neuron. I can't get to Hannah. She's too far away. There's this synaptic cleft between us. So I send these little neurotransmitters across, and they come here and they land on Hannah's receptors. And she says, "Oh, okay. So you fired. You want me to fire? Okay, I'm firing." And she sends a signal down the rest of her neuron. And that axon comes all the way over here to Ladette. But there's this space between us. Ladette, I'm trying to tell you, she's firing. You need to fire. Okay. And she sends it along. The neuron is the actual this.
Yeah, but like when they come together,
The place where they come together is the synapse between one neuron and another neuron, between the axon of one and the dendrite of the other. Cool? Yes, ma'am. Let's take a look. What do we have here? For meninges, I want you to know the function of them. Yeah.
Like the function of each layer, the function of the meninges in general.
Well, what's the function of the meninges in general? It's protection, A. You're kind of giving a little cushion layer. But then what else? Okay, there's some support absorption. Mm-hmm. You said what? There is that fluid that's flowing. Absolutely, that's cerebrospinal fluid, right? Some of that is being produced in the meninges, and it also helps with the flow of that. Yeah. So there's a lot of things that flow does. We didn't really talk much about what the purpose of that flow is, but protection and that production and flow of the cerebrospinal fluid. Those are really the 2 things I'm looking for as far as meninges goes. Just know them. I would be comfortable knowing which is superior, not superior, which is superficial, which is deep. Yeah. Yeah. So let's look. Let's look there. Here's my 3 layers right here. So here's my meninges. Dura is the white, arachnoid is the purplish, and pia is the red. So the most superficial is which? The dura, absolutely. And then you have the arachnoid, and it's that space that's beneath the arachnoid, between the arachnoid and the pia, that's where you get that blue cerebrospinal fluid. That's also where these little guys are, the little choroid plexuses, the little cauliflowery looking things that produce that cerebrospinal fluid. Okay? So that's in that, they call it the subarachnoid space is where that cerebrospinal fluid is, in the meninges. Pia is deep. So it's between the pia and the arachnoid, is that subarachnoid space.
What's meningitis?
It would be inflammation in these meninges. Yeah. Which is why they take that spinal tap because they can get some of this fluid from there without having to go into your brain. It's not fun to go into your spine, but it's better than going into your brain. Was that helpful, Krista?
What's the sensory under? Like the one with when it's like the withdrawal?
The reflexes? Yeah. That's our reflexes. Reflex arcs, 2 examples. So we had the withdrawal, you step on the pin and I'm pulling my foot back. What was the other reflex? Sure, but what was that called? We knocked on the knee. CJ was our guinea pig. Just a spinal reflex, right? But I'm looking at the actual spinal nerves. Like that, to test your knee is looking at L3 and below. L3, L4, L5.
For those examples,
Sorry? No. Right. Is that what you were going to say?
I was just going to ask for, if it said to know examples, how much we need to know about the examples?
To be able to tell me, about them. Just tell me what the examples are. Here's the reflex here. So the big key about the reflex is the signal does not go to the brain, right? So I step on a tack here. The signal travels up, and remember goes through the posterior, the dorsal root, into the spinal cord. Normally it would go straight up to the brain then, right? The brain would interpret the signal. Hey, you stepped on a pin. Please move your foot. And send it back down. But because we want this to happen, this is a protective reflex, right? We don't want it to take that long, even though that's only less than a second. We want it faster. So that's why we have these little interneurons, these little connectors, that you can just take a little shortcut, whoop, right from the sensory, right to the motor, lift it up. Yes, ma'am. This is withdrawal reflex. Yep. Yep. So that's your withdrawal. No, they're all going straight through. Yep. No, you can say patellar reflex. You're specifically talking about that one reflex. We also talked about you can do it on your elbow. There's one actually in the front of your elbow, your biceps to do it. There's one on the wrist. There's lots of other ones, but in general, those are spinal reflexes. Patellar is this particular one right here. Okay. It's good questions. Other questions?
Can you tell us how many questions are going to be on?
Enough to cover all of this.
So like one for each?
I don't know, to be honest. I don't have the test in my hands to tell you about it. I have made the test, yes. I'm saying I don't have the number to tell you. Just know the information. You'll be fine. Good question. So we're talking about the brain diagram. Oops. Oh, yes, general functions. Frontal lobe, parietal lobe, occipital lobe. Okay. See you tomorrow.